for unit number 2 and lecture 2 for unit 2. Okay. We already discussed uh, what is a transducer in our first lecture, and today we will discuss some more transducer. Uh, so today we will discuss this LVDT and inductive types of transducer, and one more is what is that? This thermistor. So these three topic we will cover today. So before starting this LVDT, I want to start this inductive transducer. Okay, because LVDT is one of the type of inductive transducer. So what do you mean by inductive transducer? A transducer is a device that convert one kind of energy or quantity into the another kind of energy into or quantity, mainly the electrical quantity. So this definition we already covered in our first lecture, and here the inductive transducer we generally deal with the uh, Faraday law of electromagnetic induction. We will see how it relate with this. So when we talk about the inductive transducer, it means there is a creation of fluxes, right? And so the basic principle of this for this inductive type of transducer is uh, self-generating uh, induct EMF, self-generating EMF, right? It work on the self-generating EMF, or those are not capable to generate the EMF. So at that time, we need to provide the external supply. So that types of transducer is comes under the category of passive transducer. Okay, so this both category uh, is both types of category we will going to see in this inductive types of transducer. So it has two main parts, namely the sensor, which is sense the input of the actuator, which perform the output part. A sensor is based on the principle of induction known as a inductive transducer. So this is the basic information. So an electromagnetic transducer is a device that convert physical motion in this an electromagnetic induction, or you can say inductive electro electromechanical transducer is a device that convert physical motion, okay, into a change in inductance. So this transducer is work on this principle. So here mainly we convert this physical motion into the electrical signal, right? So electrical signal here we are interested in the change in inductance. यहाँ पे change in inductance होगा, and this transducer are these transducer are the variable types of transducer work on the following two principle, means those are variable type of transducer here, variable types of inductance here. They are work on the basic two principle. First is variation in self inductance, second is variation in mutual inductance. So in this, the transducer which is variable types, right, variable inductance types, variable inductance type are categorized into two categories, or you can say they are working on the principle of two categories, that is variation of self inductance and variation of a mutual inductance, variation of a variation of mutual inductance. So because of this, you got some signal, you got some value on your meter that is related to your displacement. Okay, so when you see the configuration, what is the formula of psi is nothing but your, this is a flux which is nothing but your, n is a number of turn, I is a current flowing, right? And this is your reluctance. So this is a basic formula of your flux, right? This is your flux. So when you take the derivation, actually I'm not go through the all derivation with detail, but yes, when you differentiate this flux with respect to time, and one relation you know is nothing but your n d phi by dt, right? This relation, and when you differentiate it and find the relations, so you got some relation here, and when you put this relation with this value, so inductor formula is also known to you. Inductor, what do you mean by inductor? Or you can say, if there is a inductance, right? If there is a inductance, for example, there is a inductive coil, right? Inductive coil is here because of we are dealing with inductive transducer, right? So current is flowing in that circuit, that is, which is I. If I find out the induced EMF in this coil is E is equal to, there are some inductance for this coil which is denoted by L. So L di by dt, right? This is a simple basic Ohm's law. Okay, so this one relation, this another relation, and you got some relation from this when you differentiate with respect to time. So when you compare all these three equations, you got the relation of this L, which is nothing but your n square by r. Okay, r means reluctance here. So this is this relation you got when you derivate this quantity, and there is a some assumption you need to take care. Okay, here some assumption you need to take care. Actually, I have the derivation, but I am not go through that all, no, this derivation. So it is take this as your homework. Okay, take this as your homework to find out this derivation. Okay, this is your homework. Find out this derivation and put this value in these equations, so you got this relation, which is nothing but your L n square by reluctance. So here you can say, uh, b- this reluctance, this inductance of the coil is changing with respect to the change in number of turns or change in this value of inductance. Okay, so the output of the inductive transducer can be form of either change in the voltage or change in the inductance. So before that, before this relation, you got one more relation, which is nothing but your L is nothing but your E by di by dt. So this one more relation. So you can say that the output from an inductive transducer, output from inductive transducer can be in the form of either a in voltage or a change in inductance. Okay, so this is the conclusion when you put these equations on this relation. So you can say that the output from the inductive transducer can be changed, can be in the form of either the change in voltage or change in the inductance. So by these two way you can take your output. Okay, means by these two ways you can take your output. Now uh, uh, this inductive transducer can be classified into three categories. Okay, two categories. First is variation with self inductance, variation for mutual inductance. Now now if I talking about this variable reluctance type. So this variable reductance type, this is one of the example here. See, this is the structure. Okay, this is a core which is a ferromagnetic material, and in this core, a winding is wound. Okay, a winding is wound, which is an inductive, make it inductive winding. Okay, so this is a displacement. This is a linear displacement. Uh, uh, Sorry, this is a displacement depending on your displacement value. Your air gap will be increase or decrease accordingly, right? When the air gap is increases when air gap is increases then when air gap is increases, then this reluctance is decreases. Reluctance is increases, right? See, जब एयर गैप इंक्रीज होगा, व्हाट इज द फॉर्मूला ऑफ रिलक्टेंस here, inductance here? L is nothing but your n square by r, right? We already see this derivation in above. N square by r. Okay, r is the reluctance. So here, what is the reluctance? See, this is the two reluctance here. One is air gap reluctance, another is this iron part reluctance. So this is the iron part reluctance, and second is this air gap reluctance. So I can say that this equation is nothing but your n square by ri plus rg. Okay, one is air gap and another is this iron part reluctance. So as you know, this is the iron part, so I can we can neglect this iron part reluctance. So this inductance is directly proportional to the n square, directly proportional to n square divided by gap reluctances. Okay, n square divided by gap reluctances, because this reluctance air gap iron part reluctance is very low. Okay, so we can neglect this iron part reluctance, and this is in directly proportional to the n square by this rg. Now, as the basic formula of this reluctance is nothing but your reluctance. Okay, reluctance is nothing but your this is for air gap. Okay, this is for air gap. So lg divided by nu zero into ag. So reluctance is nothing but your L by nu zero A. See, this Lg is nothing but your length of the air gap. Length of the air gap. Okay, this length of the air gap. This is your Lg. Okay, Lg and Ag. Ag is nothing but your area of flux passes through that air gap. Area of flux means see what is the area of flux passes through that air gap is nothing but your this portion, right? इतने पोर्शन से ही एरिया ऑफ फ्लक्स फ्लो करेंगे यहाँ से, passes through that air gap. Okay, for this iron for this uh, uh, this iron part, right? So this is your this is your area of the air gap which is passes through the area of flux passes through the air gap. Okay, so Lg is nothing but your length of air gap. Ag is nothing but your area of the flux path through air gap, area of flux path through air gap. And nu zero is nothing but your permeability. So see, R is proportional to this Lg. R is proportional to this length, nu zero and Ag. So this all three quantity are constant, right? So we can say that this all this quantity are constant for this. This is a constant. Okay, this is a constant. So I can say that for this particular arrangement, your reluctance part is a constant, right? Reluctance of G is a constant. So we can say that this L is proportional, inversely proportional to the your length of the gap, which is nothing but the self inductance of the coil is inversely proportional to the length of the gap. Okay, when the target is near the for this arrangement, but when the target, so here is your target, this is your target, when the target is near the this arrangement, then this Lg, this length of the gap is decreases. When the length of the gap is decreases, then your reluctance is directly proportional to this, right? So this reluctance is decreases, and here inductance, your inductance is inversely proportional to the length of the gap, right? Inversely proportional to the length of the gap. When the length of the gap is decreases, then your inductance value is increases. Okay, when Lg, when Lg length of the gap is decreases, then L value is increases, right? And when Lg is decreases, then uh, reluctance of G, reluctance is decreases, right? This is the directly proportional and this is inversely proportional. So by this mean, you can say that you can make a arrangement by this mean you got the this output. Okay, because your this inductance value is changing, and by this mean you can comment it. So what is the total displacement of at your targeted this targeted part, right? सो इतना डिस्प्लेसमेंट आपको कैलकुलेट कर सकते हो बिकॉज दिस अरेंजमेंट यू मेक earlier, right, for measuring some particular range of displacement. Once you construct it, then when you use that device in particular applications, so you know this device is a measure up to the this distance. Okay, and up to this distance, and that distance is converted to the electrical signal, which is nothing but here you got the signal in terms of your this reluctance. And when the this is changing, right, reluctance is changing, that means your displacement is happen. Okay, so one more thing, this is a one way. And one more things, when you add, this is a second arrangement of variable reluctance bridge. So in this arrangement, see, this is a iron bar, the same thing, this construction is same as earlier. This is a air gap, the relation is also same, but here you are uh, supply the this power to, or you are excite this coil, right, inductive coil, you are excited this inductive coil which is wound on this limb. And one more, there this is a magnetic part you are increasing this, and this connected to the this bar magnet. Okay, so once and here your load that is which displaced is connected at one end. दिस बार मैग्नेट के एक ही एंड में आप उसे कनेक्ट करोगे व्हेन व्हेन द variation in happen in your load, right? Whenever the displacement is happen, then this point A is move upward or downward depending on your displacement. So when it goes upward side, then this bar magnet is shifted such that, right? ऐसा कुछ आपका बार मैग्नेट शिफ्ट हो जाएगा, और यहाँ पे आपका ये ऐसा स्ट्रक्चर होगा, राइट? ऐसा कुछ शिफ्ट हो जाएगा. देन this is your air gap, right? So these are two limbs which are excited, so there is a differential differences is happening here. So at this location both are equal inductance, right? Both has equal inductance, but when the when this magnet is shifted upward side, then this inductance, this air gap is reduces. This air gap is reduces means inductance is more. Inductance is more for this coil, right? When this such for this condition, inductance is more for this coil and less for this coil. So if we consider this is your positive displacement side, अगर आप इसे पॉजिटिव, दिस इज अ मिड लोकेशन, राइट? दिस इज योर मीटर which is deflect, which is sense your this deflection in terms of your electrical signal. Okay, so this is a midpoint. So this difference is nothing but your this minus this. Okay, because this is more. So depending on your predefined value, which for example एलवीडीटी में हम और अच्छे से समझेंगे इसे. ओके, सो बेसिक थिंग इज दैट व्हेन such a condition is happening, so this bar magnet is shifted down and this is upward side because the uh, external load is pulled displaced by some distance. Okay, so at that time this potential is increases, or you can say this inductance is increases because of length, air gap length is decreases. And similar way this inductance is decreases because of air gap length is increasing here, right? See, air gap length is increasing. So by this mean you can measure the differences in terms of uh, either in terms of voltages or in terms of inductance. So that will be measured by this meter. Okay, so by this mean you can measure the value of this displacement in terms of this electrical signal. Okay, and इसका जितना भी theory है, आपको कालसी कलसी बुक में मिल जाएगा. ओके, HS कलसी. Okay, so these are the arrangement for this inductive types of uh, transducer. These are the some application of inductive types of transducer. Is first is the most common application of inductive transducer is a proximity switch sensor, which is used the vital equipment safety device like crane, elevators. So इन सब में this inductive types of transducer का use हम करते हैं. Now these transducer are also useful to provide the plant to perform the programmed sequential function and counters. So this is a application in electronic devices, and in the monitoring of medical, and this is a application in your medical field. So for example in blood pressure monitoring, heart monitoring, and this. Okay, so in all these things, you can use the inductive types of transducer. Now, the advantage of this transducer, inductive types of transducer is inductive transducer can be withstand with adverse environment conditional like temperature, humidity. So this is one of the best uh, advantage. You can use such types of transducer in any weather conditions. So it can be performed in the industrial environment. This transducer has a good accuracy and consider the stable operation with a good lifespan. And this more, it can be subjected to the high switching rate required to industrial application. And this inductive transducer are available in a wide range and can be used in the several applications. So these are the industrial application. You can also use this transition into the various application of your industry level. Okay. So what are the disadvantage of with this? The shape composition of the armature uh, plays a role of selecting of the transducer. So some of the time it has to be almost tailor made. So that is the one of the disadvantage. Okay. And second one is that inductive transistor will work metallic, magnetic material. So these are the some point of time this become a disadvantage for this inductive types of transducer, because of there are so many adverse effect is happen when you use this transistor into the different application. So actual machine will be affect uh, with this point. Okay. So that at that time this point will becomes under the disadvantage of this inductive types of transducer. So this is the inductive types of transducer. So one more type is LVDT. LVDT also the inductive types of transducer. So now we will discuss the LVDT. So these are the basic structures of LVDT. See, what is the first of all, what is the full form of LVDT? LVDT is nothing but your, wait a minute. Yes, LVDT. LVDT is nothing but your linear. LVDT is stand for linear variable. Okay, linear variable differential differential transformer. LVDT stand for linear variable differential transformer. Why you are calling this transformer? Because see, there are the two windings, primary and secondary winding, are situated such that like a transformer, right? This is a one of the core are given here, and this winding are wound on this core. So, for example, this structure is similar. So this is your primary winding, and the secondary winding are partly wind on this upper side and this below of this primary winding. And output is taken on from this position, which is in terms of your electrical output. Okay. So this input, this these are the input. Excitation is given to this. So what do you mean by this? If the input is provided to this winding, it means that your LVDT is nothing but your passive types of transducer, right? So it is a passive transducer. It is also find out this reading in this meter, like so this is nothing but your analog meter. So you can say that this is your analog transducer. On the basis of principle, when you talk about the on the basis of principle, so there are two coils are there which is wound on this core. Okay. So inductance is involved here, right? So it works on the mutual inductance, variation of the mutual inductance, you can say, because two windings are there. There are the mutual effect is also happening here, depending on the displacement. This induced emf on this coil, with this coil is also changing depending on the depending on the displacement. You can say that it works on the principle of on the principle of works on the principle on the principle of inductive transducer. Okay, it works on the principle of inductive transducer. See, this is a soft iron core. Okay, this is a your soft iron core, and this is a one bar is connected to this, and here the displacement is happening. Okay, whenever the displacement, and this shaft is initially is in front of this, right? So यहाँ से जितना भी आपका EMF इंड्यूस होगा, that induced EMF is in between this it linking with this soft iron, right? So you can say when you displace this iron in this side, this is the left hand side and this is your right hand side. So when you displace this iron to the left hand side, this is your left hand side. So what are the maximum linkage flux linkage maximum कहाँ पे होगा? Flux linking maximum in front of this S1. Okay, this is a secondary winding S1 in front of this S1 side. So S1 side it produce maximum amount of induced EMF. Okay, because more flux linkage are with this at this position. So uh, so at that time this S1 is responsible for the E1, right? I can say this is responsible for the E1, and this is responsible for the this is ES1, and this is for ES2. Induced EMF for secondary winding for first, and this induced EMF for secondary winding two. Okay, so this is your left hand displacement, and this is your right hand displacement. So when this soft iron core is displaced to this left hand side by mean of displacement of your external load to the left hand side, जब ये एक्सटर्नल लोड यहाँ इस साइड में मूव करेगा, ओके, लीनियर डिस्प्लेसमेंट टू द लेफ्ट हैंड साइड, देन दिस सॉफ्ट आयरन आल्सो पुल to the left hand side of this. So at that time the maximum flux linkage is with in front of this S1, right? Secondary winding of S1. So ES1 is greater compared to the ES2. Now at present location, this ES1 is equal to ES2. Now depending on the location of this soft iron, that ES1 and ES2 is changing. So that is nothing but the due to the effect of the mutual inductance. Uh, okay. Now see one more thing. Now see, this is a AC excitation. Okay, AC excitation to given to this primary winding, which is given here. See, both structure are similar. Okay, so this is a primary structure. So here this AC winding excited. So secondary winding are also there. If the excitation is happening here, so flux is involved around this coil. So that is linking with the secondary side of the coils, right? Because both the secondary winding are placed above and below of this, and one more both winding are connected to each other, right? Just like with the help of this wire. Okay, actually this is a okay. Now and this is output is one of the input is taken from this primary, and another is taken from this your secondary coil. Okay, now sorry, this output is taken from the one of the end of this secondary प्राइमरी दिस सेकेंडरी के फर्स्ट एंड से लिया है और सेकेंडरी के लास्ट एंड से सेकेंड कॉइल लिया है. एंड हाउ टू टेक दैट आउटपुट इज जस्ट लाइक दैट. द सीरीज अपोजिशन में हमने ये आउटपुट टर्मिनल कैरी आउट किया है. ओके. So by mean of the induction, the EMF induced in these coils, right? So depending on this displacement, आपका जो ये core है, iron core, they are displaced. So at the rest position, or you can say at initial position, this ES1 is equal to the your ES2. So at core at core at mid position core at mid position. So this is called your null position. So here E output is nothing but your 0, because both ES1 and ES2 are equal. So this position is called as a null positional condition. So when the core is displaced when core displace left hand side, then this es1 is greater than of es2, right? So in this case es1 अगर बड़ा है, so e output क्या होगा? E output is nothing but your es1 minus es2. So es1 is greater than, this is positive, right? And if this is positive, so you can say that this is your 0 degree phase shift, right? 0 degree phase shift, 0 degree phase shift, right? सो एट मैक्सिमम कंडीशन क्या हो सकती है? एट मैक्स एक्स मैक्स कंडीशन, at max condition this core at max condition. So this is a shifting, right? At max condition आपका core कैसा हो सकता है कि आपका core पूरा यहाँ पे हो, right? This is your bar, and this is your displacement. So at max position, this all core is appear in front of this. So at that time the es2 is 0, right? Es2 is 0 and es1 is maximum, es1 is max, right? So at max condition, so this e output is nothing but your es1, okay, and es2 is 0 for this. The same way, this is the displacement to the left hand side. So this is your left hand side and this is your right hand side, okay, and this is your right hand side. The same condition is happening when when you consider the displacement on the right hand side. So I hope this is clear to you. When core displace right hand side, okay, then es2 is greater than of es1. Now this is a mid position, right? So this e naught is either maybe positive or negative. So here e naught is negative, which is denote 180 degree phase shift, 180 degree phase displacement, or you can say phase shift. Okay. At maximum condition, at max condition, e naught is nothing but your minus of es2. Okay. So by this way you can say that this is the output voltage by mean of the induction principle. So output voltage is directly proportional to the output voltage output voltage directly proportional to the displacement. We also see the some numerical depend on that. One more thing, if you draw the graph between these, if you draw the graph between these, then you find out this is your output voltage, and here you got the left hand side displacement. Okay, and here is a, sorry, this is your right hand side displacement and this is your left hand side displacement. Okay, now at initial this is the advantage of this LVDT. At the initially or at some point of time, you got the linear region. Okay, so this is a linear region, but when you exceed the range, you got the, your curve will be like that. Okay, it changing like that. So at the some point of time, this is the advantages for you. So by using this LVDT, so that's why this LVDT has a most of the application, because at some point of time it got a linear region. So this is nothing but your linear region. Okay, but after when you increase the range of this, so your this region also get in changing. So here, sorry, this is your left hand side, right? Because we are changing the, see, this is your left hand side, this is your right hand side, because I consider here this is your zero null location, right? And this is negative side, and this I consider as a positive side. So that's why this is your left hand side and this is your right hand side. So this phi is nothing but your 180-degree phase shift here. We denote negative sign, and here phi is nothing but your 0-degree phase shift. So here this shaded region, this dotted region is denoted as a linear region. Okay, linear region, or you can say linear range. And this is because of the, these are the inductance, so it follows the residue this BH criteria, right? So there are the residual magnetic field also are created here. So at once you use, so there are some magnetic field also with that. So you can say this is your this is nothing but your residual voltages. Okay, this is your residual voltages. That's why in most of the book you found out this graph is started at some above the point of this zero voltage to above, means there are some point of voltages. Okay, so that's the uh, characteristics of this LVDT. Now the see also some advantage of LVDT. This is a linearity, infinite resolution, and high output. So these are the some advantage. So you can just read it out. Okay, I'm skipping this advantage and disadvantage now. Okay, thermistor point is also left. Okay, these are the question. Try to solve it. The output of LVDT is connected to the 5 volt voltmeter through an amplifier whose amplification factor is 250 volt. Okay, whose amplification factor is 250 volt, and output is 2 millivolt appear across the terminal of LVDT when the core moves through the distance of 0.5 mm. So जो हमारा core है वो 0.5 mm से move किया. Then calculate the sensitivity of LVDT, that is the whole set up. Okay, so sensitivity you need to find out. Sensitivity का formula क्या है? Change in output upon change in input. So what are the input here is displacement, right? So whose set so आपका जो core है वो upset में move हुआ है. Then the millivoltmeter scale has 100 division. So this division is also provided you. The scale can be read to 1/5 of the division. So you need to find out the resolution here. Okay, so by that resolution you can clearly read out the this division. Okay, and this resolution in mm. So sensitivity आपको यहाँ पे थी, right? Calculate the sensitivity of the LVDT. What are the sensitivity formula is change in output upon change in input. What is the change in input here? Sensitivity of LVDT I can say, so you can directly use output voltage upon displacement here. Output voltage upon, because the output is a voltage, right? And what are the output voltage? Then output of 2 millivolt, and displacement is output is 2 millivolt. Millivolt convert into volt, and distance is 0.5 mm. So you need to find out this in mm. So इसको उसी में रहने दो, which is nothing but your 0.5. When you solve it, you got you will get this 4 into 10 to the power of minus 3 volt per mm. Okay, or you can also say that 4 millivolt per mm. Now the second thing is that the sensitivity of instrument is nothing but your amplification factor into sensitivity of the this LVDT. Amplification factor is given to you. Use that amplification factor to find out the sensitivity of the instrument, and simple, you need to multiply the this multiplication factor with the sensitivity of your LVDT. Okay, so by multiplying this, you got the whole instrument sensitivity. So what are the amplification factor here is amplification factor amplification factor is 250. So multiply this 250 with your sensitivity of this 4 millivolt. So 250 multiplied by 4, what is that? When you multiply with this, so this is nothing but your 4. 4 convert this millivolt, use this 4 into 10 to the power of minus 3. When you multiply this, you get 1 volt per mm, or you can say 1000 millivolt per mm. Now you got the sensitivity of your whole instrument. Now the cells, one scale division one scale division कितना होगा यहाँ पे? one scale division one scale division is nothing but here. What are the voltages, output voltage? So the output of LVDT connected to the 5 volt. Okay, so 5 volt is your voltmeter reading, and what are the number of division for this instrument is 100 division. Okay, so 5 volt divided by 100, so that is a one scale division, which is nothing but your 5 volt divided by 100 here, which is a 50 volt, 50 millivolt you can say, because of 0.05 volt. So convert into the in millivolt. So one scale division is nothing but your 50 millivolt. Now the minimum voltages that can be read on the voltmeter is nothing but your कितना था उसमें स्केल, वन फिफ्थ था, राइट? one fifth of division. The scale can be read by the one fifth of the division. So multiply that one fifth of division with your one scale division range. One scale kitna hai? 50. So 50 multiply by one fifth, which is nothing but your uh, one fifth is 10 millivolt. right? Which is nothing but here 1/5 multiply by, okay, so this is nothing but your 10 millivolt, right? Now the resolution, mm, uh, now the resolution is resolution of instrument कितना आया resolution is nothing but your this minimum voltage that can be read, which is nothing but your 10 millivolt divided by uh, your sensitivity, which is this, right? So 10 divided by, so what are the sensitivity here is 1000. This unit is millivolt and this sensitivity unit is millivolt per mm. Okay, so when you solve this, you got 1 into 10 is to power of minus 2 mm. Okay, कैलकुलेशन देख लेना, आई थिंक ये सही होगा, बट स्टेप्स यही है. ओके, नाउ सेकंड थिंग, सेकंड क्वेश्चन इज and AC LVDT. Okay, and AC LVDT has the following data, which input is 6.3 volt, output is 5.2 volt, and the range is here plus minus. Okay, plus minus zero point 0.5 inch. Okay, range is given in your inch. Okay, determine the calculate the output voltage core position of the core position for the core movement going to the कोर मूवमेंट कितना है इसका 0.45 इंच टू द माइनस 0.30 इंच तक इसका कोर मूवमेंट दिया हुआ है. नाउ फॉर सेकेंड you need to find out this, the output voltage of the core is minus 0.25 inch from the center. Okay, so अब यहाँ पे आपको दो चीज दी हुई है. ओके, सो फर्स्ट इज आपको इसका रेंज दिया हुआ है एंड सेकंड इज आपको इंडिविजुअल इसका आपका कोर का रेंज दिया हुआ है. सो यू नीड टू फाइंड आउट द आउटपुट वोल्टेज हेयर. सो फर्स्ट कंडीशन चेक लेते हैं हम. व्हेन आई टेक फर्स्ट कंडीशन विच इज नथिंग बट योर, ओके, 0.5 inch, right? 0.5 inch is given to you. 0.5 inch core displacement produce, how much produce 5.2 volt. Okay, 0.5 inch of core displacement produce point 0.5 0.2 volt. So here the linear relation I already told you in LVDT, linear relation will be set up. Okay, so zero point 0.5 से 5.2 वोल्ट है. सो 4.5 में कितना होगा? 4.5 इंच डिस्प्लेसमेंट में हाउ मच वोल्टेज is show on your meter. So take the ratio of this all four things. So let it be x volt. Okay, so this x volt is nothing but your x is nothing but your 0.45 divided by zero point 0.5 multiplied by 5.2. Okay, multiply these things, you got some voltages here, which is nothing but your I think 6.4.68 volt. Okay, Similarly when we find out, so this is your first condition. Similarly for minus 0.30 displacement, minus 0.30 inch displacement, what are the responsible voltages here? Now see this displacement in terms of minus, so probably your voltage may be got in minus, right? Because this location of your co this ma- uh, location of your this meter in mid terms, right? Because see here LVDT locations, ये मिड में होता है, ओके। यस, सो ये मिड में होता है आपका, अगर ये इधर भी हो सकता है इधर भी हो सकता है, तो मे बी इट पॉजिटिव और नेगेटिव। यहाँ पे भी हमने चेक किया था, ओके। डिपेंडिंग ऑन दैट योर आउटपुट वोल्टेज में बी पॉजिटिव और नेगेटिव। सो यहाँ पे same way you need to find out the relation, you need to take the ratio of these all things, so you can easily find out this also. So try to solve it, this is your homework, okay। फाइनल आंसर बता देता हूँ मैं। सो दिस आंसर आई थिंक यू विल गॉट -3.12 वोल्ट। कैलकुलेशन देख लो आप यहाँ से। सिमिलरली फॉर सेकेंड क्वेश्चन ऑल्सो, displacement you got a displacement that is -0.25 inch. The core movement, this is a core movement, so what are the responsible voltages here is you will got 2.6 volt, okay। Do that calculation and match your answer. Now one more topic is thermistor, so let's finish। thermistor क्या होता है? It is one of the type of instrument which is measure the temperature, okay। So by mean of the variation of the resistance of different kind of material, okay। So there are four types of discs depending on their application. You are construct the discs according to these four types. First is disc type, second is rod type, third is washer type, and fourth is bead type, okay। So these are the thermistor type. Now this thermistor is electrical, okay। The electrical temperature is depend temperature का relation को पता होगा I think। So for example resistance, these are the resistance for new resistance for, or I can say resistance 1, which is nothing but your R naught 1 plus of alpha T, okay। These are the basic relation of your resistance. You might be studying in your first year or third sem in network. So here the alpha is nothing but the temperature coefficient. Actually, here is nothing but your change in T. Okay, this is nothing but your change in T, right? Change in temperature. Okay, this is a temperature coefficient. Okay, temperature coefficient. So this is the temperature coefficient. So thermistor has a negative temperature coefficient. Thermistor has a negative temperature coefficient. So and one more thing, thermistor is made up of two words, that is thermally, thermal, this is therm and ester, okay। Therm and ester means, now see this therm is meaning of this term is nothing but your thermally, okay। This is nothing but your thermally, and this ester means sensitive, thermally sensitive resistor, okay, resistor। So see this thermistor is nothing, this therm is nothing but your thermal, and this ester is nothing but your resistor, okay, this ester। So this is the device which is sensing the temperature by mean of the uh, change in their the resistance, okay, by mean of the change in their resistances। सो इट हैज़ अ नेगेटिव टेम्परेचर कोएफिशिएंट, दैट इज वन एडवांटेज, मीन्स आपका जितना भी टेम्परेचर राइज होगा आपका रेजिस्टेंस डिक्रीज होगा, राइट। फॉर नेगेटिव टेम्परेचर रेजिस्टेंस सी, अगर आपका कोई पहले कुछ और रेजिस्टेंस था, सो न्यू रेजिस्टेंस बिकॉज ऑफ माइनस द नेट रेजिस्टेंस इज डिक्रीजेस, ओके, बिकॉज ऑफ दिस द टेम्परेचर कोएफिशिएंट इज नेगेटिव. So that will be the one of the advantages of this thermistor. By mean of this, you can change the uh, at a higher level of temperature as well. ओके, सो ये तो रेजिस्टेंस का रिलेशन है. फाइंड आउट यहाँ से टेम्परेचर का रिलेशन इन टर्म्स ऑफ दिस कोई टेम्परेचर कोएफिशिएंट फाइंड आउट करो, ये होमवर्क है. मुझे ये याद था अभी तो मैंने ये बता दिया. सो yes, there is a relation with this temperature coefficient in terms of your temperature and your resistance. So find out that relation or derive that relation. Okay, alpha in terms of your this resistance and temperature, function of resistance and temperature. Okay, find out करना ये relation. Okay, so that is a one of the types of thermistor, this Dix type, rod type, washer type, and this braid type. So these are the some functional arrangement of thermistor. Okay, so this is a thermistor washer, and depending on the temperature, that is this sensing. Depending on the temperature changing, your resistance value is also changing because both are proportional to each other, right? Now, these are the advantages of the thermistor and these are the limitation of the thermistor. So please go through this advantage and disadvantages. And these are the one example which I want to take. So सी इसमें जनरली इसका एक ग्राफ होता है. ओके, सो इस क्वेश्चन में ग्राफ तो एक्चुअली फिगर बनाना भूल गया मैं इसमें. The figure is given to you is A, this is your emitter, this is your R1, okay, and this is your RC, and these are the position of your this device, port of the devices, right, which is changing. Depending on that, your value, you will get the some value in your emitter. Okay, this is the terminal voltages, and this is your RT. So these are the arrangement for this question. This is the circuit, and the information is given to is that the thermistor has a 4K ohm type. The meter is 50 milliampere meter with the resistance of 3 ohm. So इसका 50 milliampere है, इसका 3 ohm है. RC is said to be 17 ohm. RC is said to be the 17 ohm, and supply is VT is 15 ohm, 15 volt. What will be the meter reading? So what will be the meter reading at 77 degree Fahrenheit or 25 degree Celsius at the 150 and second, this is the first and this is the second, okay, at 150 degree Fahrenheit. So here assumption is given, or this value you can also find out with the help of graph. Okay, so assume the thermistor resistance as a 25 degree Celsius, it has 4K ohm, and at 150 degree Fahrenheit is 950 ohm. So these are the thermistor resistance. Thermistor resistance. So these are the thermistor resistance which you design. So that value you already known, right? And which you want to measure. So that value you can easily find out with this. Okay. So what are the current here? Simple Ohm's law लगा दो यहाँ पे. Okay. So what are the value of I? I is nothing but your VT by RT. VT by RT. RT here is nothing but your total of this. Okay, RT ये this thermistor resistance नहीं है. These are the total resistance. Okay, so what are the total resistance here? is 15 divided by for this, or this is for first condition. Okay, so this is for first condition, which is temperature at 77 degree Fahrenheit, or you can say 25 degree Celsius. So at 25 degree Celsius कितना है, 4K आपका at this is for at 25 degrees Celsius. So what are the resistance value is 4K. So thermistor resistance आपका कितना है, 4K. 4K प्लस ये RC रेजिस्टेंस आपका 17 प्लस एंड थर्ड इज मीटर रेजिस्टेंस आपको दिया है 3 ओम का. ओके, ये आपके मीटर का कोई रेजिस्टेंस होगा, वो भी 3 ओम का दिया है इसमें. नाउ फाइंड आउट द वैल्यू ऑफ दिस I think you will got this 3.73 milliampere. Guys, 2 minutes more. एक मिनट रुको. सेकेंड थिंग में क्या है इसमें, सेम वैल्यू, बट at the second time you need to take resistance at 150 degree Celsius, degree Fahrenheit. Okay, so at this temperature your thermistor resistance is 950 ohm. So current value is nothing but your 50 volt is the output voltage, and resistance is 950 plus 17 plus 3. So these terms are constant, and this thermistor temperature is changing depending on your conditions. Okay, external condition, it is changing. So with the help of this you can find out the value of current here. So when you solve it, you will get 15.5 milliampere. So ये सिंपल कैलकुलेशंस है इसमें. एंड थर्मिस्टर and LVDT, thermistor, LVDT, and this inductive types of transducer. It has used application in our real life. So please go through this topic in your book as well. इसका डिस्क्रिप्शन, मोर डिस्क्रिप्शन के लिए आप कौन सी बुक है ये, कालसी बुक का यूज कर सकते हो. ओके, यस गाइस, थैंक यू. कितने जन है? ओके, मंडे से आपका क्लास ऑफलाइन है क्या?